Hello everyone. The title of this talk is a bit long. It's basically introduction to the workshop which will be tomorrow. It's about electronics and building a game console. So let's hear what will happen tomorrow.
Okay, thank you. Hi everyone. My name is Marjan Urekar. Today I will talk about some basic stuff you'll need to know if you want to build a project by our distinguished colleague Voja Antonić. It's one chip game controller pictured here, and my main idea was that most of you guys are software based and maybe lacking some basic knowledge in hardware, so I'll try to explain some basic stuff you'll need to know in order to build this controller. This controller is do-it-yourself kind. You get bare printed circuit board, you get parts, and you need to assemble it, solder it, test it, and operate it. Let's see how it's done. So, this is the link to the build. This is how the board looks, exactly like this. It's small, compact, and neatly designed. This is the one game it contains. It's based on old jumping jack game. This is what you need to do in order to get this console working. You get PCB, you get the electronic parts, you solder it, assemble it, test it before playing it, and you can have fun and play with it later. So this is the beginning. This is a so-called printed circuit board. This is where all the parts go, and you need to solder your parts to this board. On the first picture you get top layer of this printed circuit board. It has a silk screen with all the components, and this is where components are placed. This is the bottom of the circuit board, and this is where you solder your components. Don't mix it. And this is the list of parts we'll be using to assemble it. Resistors, capacitors, transistors, diodes, quartz, integrated circuits, push buttons, and connectors. I'll talk about each topic. If you are getting your own parts, you must know to get so-called through-hole parts, not small SMD components. They are very tricky to be soldered, and this board is only for through-hole parts. We'll talk about what parts you need to use, because parts vary in mark, in pinout, type, name, and package. So you have to be very careful about that. We'll see what goes where. And don't rush it. You need time to build it. So don't go too fast, especially if you are not experienced. So, first topic are the resistors. These are small resistive components. They are marked with colors. Their value in resistance is marked with 4 or 5 bands of colors. They all have standardized values. We'll talk about tolerance. Each resistor has some tolerance. So this is the example. If you get 100 ohm resistor with 5% tolerance, the real resistance is somewhere from 95 to 105 ohms. If you get more precise resistor, you'll get smaller variance, and these resistors are more expensive. You can use two types of resistors, carbon film and metal film. Carbon film are older, they have larger tolerance, 5%. Modern metal films are 2 or 1%, so very precise. Metal film are usually blue in color, and carbon film are some brownish color. You can distinct them. You can use both of them, you can mix them. It's not critical in this build. And this is the nightmarish look on how the resistors are color-coded. You need to know that in order to place the correct resistor in each designated place. What you need to know, there's a table. Each color is connected to one number. So black is 0, brown is 1, red is 2, orange is 3, and so on. And this is how it's done. You get 4 or 5 color bands on resistor, and you can break your little cells in brain about this, or you can use a phone app to decode it. But the simplest way to decode it is to obey this rule. If you use 4 bands, we can call them ABCD bands. What's the value of the resistance? It's AB. AB is a 2-digit number. Exponent is C, plus minus d% of tolerance. So, in example, you get yellow, violet, red, gold colors on the resistor. We decode it as 4725. What that means is 47 times 100 plus minus 5%. It makes 4.7 kilo ohms resistor. You can find 4K7 notation on some schematics. It means the same as 4.7. 5-band resistors use this rule, ABCDE. ABC is 3-digit number times D exponent plus minus A %. So if we get brown, green, black, orange, red, we get 15032. That means 150 times 1000. That means 150 kilo ohms plus minus 2%, because red is number 2. You can find also just 150K ohms on schematics. We can skip that. This is something I prepared for future builders. You don't have to waste your time on identifying which color is what. So these are all the values we will be using in this project. So we get 51 ohms, 120, 1K5, and you get all the codes, and I gave you examples for 4-band and 5-band, depends what you're gonna use. I'll skip this. So this is just for future use. You'll get this on the site of conference, and you can use it tomorrow or anytime, so you can speed up your building time. These are all the types we're gonna use. AS, we're gonna use 1 meg resistor. This is the largest one. 1 meg is 1 million ohms. More simpler way to find which color, which resistors are which, is to use multimeter in measuring the resistance. I talked about that last year, so you can refer to my last year presentation. When placing resistors, find their appropriate place. You can use 1/8 or 1/4 watt types. This denote what's the power it can sustain. 1/4 is bigger and it can tightly fit in the place. The prototype uses the 1/8 of watt. We'll see. These are smaller ones. You have to bend the leads of resistor at 90 degrees and to have space of 0.3 inch between the leads so it can be put in the designated place. Capacitors. Capacitors we're going to use here are ceramics. They're brownish in color or blue, square or round, disc shaped. They're very cheap and you can find them everywhere. On the picture on your right, you can see how the capacitors are noted, but we're going to use just two values, 100 nanofarads and 27 picofarads. This can be very problematic for some of you because depending on the producer, 100 nanofarads can be marked as just 100N or 104. What's 104? Well, that's 10,000 picofarads. These ceramics, round ceramic capacitors are usually marked in picofarads, so 10,000 picofarads. Or you can find American type of marking where it's just 0.1 or just 0.1. That means it's in microfarads. 0.1 microfarad is 100 nanofarads. It's all the same. And you can also use multimeter to measure the capacitance. 27 picofarads is marked just as 27. As I told you that the ceramics are marked in picofarads by default. So a line beneath the number means it's for 50 or 100 volts. That's not very important for this project. If you don't have 100 nanofarads, you can try something between 10 or even 20 to 220 nanofarads. It's not very critical. For C9, you will see that in a schematic. You can try an experiment. This is the filter capacitor, and you can vary the higher frequencies in audio and get some more electronic sounds. 27 picofarads can be used as 22 if you don't have 27. It's almost the same. Voltage is not important here. Lead spacing. Capacitors have leads. Smaller capacitors have 0.1 distance between leads. Little larger have 0.2. 100 nanofarads on the PCB are made for 0.2, but if you get smaller ones, you can fit it if you spread their pins a little bit more. 27 picofarads are very small and they have just 0.1 inch lead distance, and you can't fit larger ones in there. What's 0.1 inch? Well, that's the distance between two pins on plastic dip chip you will be using. So you can make a relation to that. For larger capacitors, we must use electrolytics or tantalums. Tantalums are better quality electrolytics, and they have advantage that they are very small, and because we have very limited space here, especially in the height. We must use tantalums if we want to make this in this sandwich between two plexiglass. Electrolytics are a little bit higher and larger, so they may be, no, not maybe, they for sure can be fitted in this sandwich. But if you lose this upper layer of plastic, you can fit anything you want. It depends on you. But C6 must be tantalum, others are not necessarily. Something very important about capacitors of electrolytic or tantalum type, they are polarized, so they have plus and minus electrodes, and you must place correctly on PCB and orient it as it must be. On the left you have electrolyte, on the right tantalum, and you see that tantalum is tear-shaped, so it's very specific. It's almost always bright yellow or orange color, and they have plus noted on one side. Electrolytics have minus noted on one side. You must look at the PCB and find mark for plus or minus. Also, if you don't have 4.7 microfarads, you can also use 10 microfarads. And for that matter, this prototype uses 10 microfarads. And you can sometimes find tantalums noted at 475. That means 47 times 5 exponent in picofarads. That's 4.7 microfarads. Don't be similar to the resistor coding. There's something we must talk about is voltage rating. You can see that there's an inscription on both capacitors 35. That means 35 volts. This is the maximum voltage it can sustain. Because we have here maximum voltage of 5 volts, we can use anything above that. Tantalums are very susceptible to damage if you place too large voltage on them, so you must get appropriate voltage. So anything above 10 volts is okay. If you use too large capacitors, they won't fit in this board. There's a slight omission on this board. You see on that picture, C6 as example, you need some plus sign on plus side of the capacitor, but it's missing from the PCB. But you get a square pad. Square pad means it's where the plus of the capacitor is. So on the square pad you place the plus of the tantalum. Don't mix it, don't turn it around because it can explode. Okay. Next stop are the transistors. We use 4 transistors in here. BC547 is preferred kind, but you can use almost any general purpose NPN transistor with the correct pinout. Pinout means that pins must be in some specific order. If you look at this transistor, you'll see that it has one flat side. If you look at the flat sides from the left to the right, you get collector, base, and emitter. And this is what must your substitute transistor have if you want to use some other kind. This is the footprint on the PCB for T1. If you want to test transistors before soldering, you can use your multimeter to find if they are correct type or if they are working. The case in here is called TO92, and any transistor of NPN type with this case can be used such as BC238 or other types. So it doesn't have to be exactly BC547. They are all working. Okay. Next up, diodes. Diodes have two pins, cathode and anode. Cathode is denoted with a black band on one side of the diode. Diodes we're going to use are 1N4148. These are common signal, small signal diodes. You can use any diode with similar characteristics, and be very careful when placing it on the PCB. You get the band for cathode on PCB also, and it's also denoted with square pad. So just be careful and take your time. You can test diodes with multimeter. It must conduct in one way. When reversed polarity, they can't put any current flow through them. You can use 1N914 instead. These are all the same. Just don't use Schottky, Zeners, and big black rectifier diodes. For matter of fact, on this picture we get a black diode, and that's the rectifier. That's a wrong diode for our use because they are slow. LED diodes. We get one LED diode in here. You can use almost any shape, any color. In here are 3 mm, but you can also use 5 mm if it has correct pin spacing of 0.1 inch between leads. What's most important about LEDs, they must be also oriented correctly. Cathode is, as normal diode, denoted with square pad. And if you reverse it, it won't work. So how to identify the diode where the cathode, where the anode? Put it against the light, and you'll see one large electrode. Larger electrode is always cathode. Sometimes you get shorter pin for cathode or some slice on the body, but the most precise way to determine which electrode is cathode is by looking at the electrodes against the light. Quartz. Quartz is your timing device, 8 MHz. It's a crystal oscillator. Here we use a shorter type because of the height constraints. So you don't use that regular higher one, you need this smaller one. They can be put any orientation you want. They are not oriented. I found one little feature not documented. You can use 3-pin oscillator. They are sold as this 3-pin type. It means it has built-in two smaller 27 picofarad capacitors. If you use this, then you don't install C7 and C8 27 picofarad capacitors. They're already in this package. So with this you use capacitors, with this you don't need to. That middle pin can be used for that third pin, or not if you use 2-pin variant. Am I correct? Integrated circuits, we use a 3-pin voltage regulator for regulating voltage at 3.3 volts. Pin out is very important. it's ground, voltage in, voltage out when you look at the flat side of the body of the integrated circuit. For a matter of fact, it looks exactly like transistor, so don't mix them up because they look the same on the board. IC2 is for this regulator, not for the transistor. And the main chip is this PIC microcontroller. It's a very delicate part, and be very careful when soldering it. It has 28 pins. It goes from pin 1 down to pin 14, then 15, and up to 28. This is the standard way to mark pin numbers. On the bottom, on the top part of the body of the chip, you get a slight indent or cutout, and this means this is the top of the chip where the number 1 goes. Sometimes it has a little dot printed beside number 1 pin. This is important because you have to put this chip in right way. So you see on this picture left, there's a slight indentation on the one side of the chip, and this indentation must be on the right side of the PCB board. Don't turn it around. If you are new to this game of soldering, you can try and use this integrated circuit socket. You solder it, and after soldering you just put your chip inside of it, so there is no danger of overheating your chip. But again, it won't fit in this sandwich. You must leave out this top layer of plexiglass. But if you are using soldering iron for the first time, that's maybe not a bad idea to use, because this chip is the most expensive part in this build. Push buttons, well, these are not the switches, because push button makes contact when pressed, and when released there's no contact. In this build we use square push buttons, or any other kind if you leave out this template of plexiglass. Push buttons also have pin out. You can use 2-pin or 4-pin models. They are called single pole single throw or single pole double throw. You see there's a place for both types on the printed circuit board. Just be careful when using 4 pins. Find out which pins are connected short when pressed, and put those pins on the opposing sides of this printed circuit board. Connectors vary in shape and type. First connector is the number 1A. It's coaxial 2.1 millimeter for PCB, because you get also variants for housing, and this is just for PCB. On the right is the correct type of connector. In this build, positive voltage is on the pin inside of connector, and outer sleeve is negative. Some voltage regulators, external power sources, use reversed logic where ground is in the middle pin, so test it before using it in this way. And on the left you get the socket, the plug that goes in that socket. This is mini USB connector. On the right upper picture is the correct type that you need. Bottom picture is not correct. Why? Because it's for surface mounted devices, and this is not the case, so we need through hole that has these protruding pins that go through the whole PCB. And this is the footprint of that connector. And very important, you get power from mini USB. You don't connect this controller with USB. USB is used just for powering. And you can power your device from the USB or from external voltage. Don't use both of them in the same time, just one. Next connector is DB15 for VGA. It's called female from the obvious reasons. On the bottom are the wrong types. Why? Well, first one is male connector, second one is too large to fit in this board, and on the right side is type of the connector that is meant to be placed in the housing of computer or something else, not for the PCB. For PCB, it must have these pins in that exact order as on the PCB itself. Next connector is audio connector, standard 3.5 millimeter stereo type. It's classic that is used on most mobile phones. You need this type with 3 pins. You can also get this type with 5 pins, and it can't be fit in this board. And on the right you get some even more complicated jack. It's not suitable for this board, so we need this type. Next, this is what you get to connect to outer space with audio. We need stereo connector. On the sleeve is ground, tip is left channel, and ring is the right channel. 2 more connectors. Connector 5 is 5-pin header that has 90-degree break on it, and you can't use this flat one because it won't fit. It must go from the side, and you get also a footprint on the PCB. 2-pin header is also at 90 degrees. You can't use just a straight one. Or you can use it, but then you have to lose this top layer of plexiglass again. Why am I losing so much time on this talk about connectors? This is some of the types of audio connectors, of coaxial connectors you can get. You see there's various types, and most of them can't be fitted in this board. So be very careful when choosing the right kind. Also for audio, there is even more variations, so be very careful when you get your parts. You need to assemble it, to solder it. You'll learn about that on the workshop that we will make for you tomorrow. When you're finished, you must test it before using it. How we can test it? Well, we must use multimeter. You put multimeter in DC range for 20 volts if you have manual ranging multimeter. First check the external power source, as I told you before. On the outer layer of metal it must have minus, in inner it must be plus voltage. If you are using USB for power, you don't have to check it, it's polarized as it should be. When connected power, LED diode is lit, and it means it's working as it should. Then you have to use a multimeter to test at least two voltages, 5 volt and 3.3 volts. What's this plus minus 3%? Well, when voltage regulator is made, it has also tolerance, just like resistor. So if the voltage you are measuring is in an area of plus minus 3% from 3.3 volts, it's okay. Also, 5 volt can be plus minus 5%. Where you make this test? Well, you can put your black or negative side of the multimeter on the ground shield of the mini USB connector, and on the middle pin of that connector, coaxial connector, you must measure something around 5 volts. On the pin 28 of the chip, you must measure 3.3 volts. If you measure these voltages, that means it's most probably okay. You can also use one last test, is to test audio. Audio pin must have DC voltage around 1.6, 1.7 volts. If you connect to monitor and you get the picture, it's fine. If audio works, it's fine. If it's not working, check this point here on one side of this resistor. You must have 1.7 volts. If it's not, there's some problem. What's the problem? Well, you must figure it out. It's most probably wrong orientation of some part, or bad solder, or some cross short circuit on board, or something is faulty. This is how the bottom of soldered printed circuit board looks. This is correctly made printed circuit board. What's the most usual problem when soldering these pins on 28-pin chip? You can get short circuit between, for say, these two pins, and you must be very careful not to connect these neighboring pins. Also, some pins can have so-called cold joint solder when you are not making very good connections, so it must be heated properly, and you must put enough solder to make a good contact. And this is the schematic. This is what we are measuring here: 5 volts, 3.3 volts on pin 28, and up there on connection of R14 and R19 we get 1.7 volts DC. If you look at it with oscilloscope, you'll see it's not just DC there, there's also AC component from the audio that is made by mixing all the outputs. What we can also say, yes, you can mix these transistors and put it the wrong way around, so you must test that emitter is at the ground and collector is at the high voltage. Also, what can be, if you have good oscilloscope, you can test these pins here if it has 8 megahertz oscillation. You see we have here 1K5, 1K5, 6 resistors. If you don't have 1K5, you can use, for say, 1K, all resistors, but they all have to be the same. Also, You see we have 51 ohms there. Can I put there 47 or 56? Well, most probably yes, but they all have to be the same. And this is very important, C6 must be tantalum. And that's about it. You don't want to mess with this schematic too much. Just check it. If all voltages are okay, then you can use it. Why have I told you that you can't use two connectors for powering in the same time? Well, you see, plus side of the USB and plus side of the coaxial connector are just shorted. And if you use both of them, you can fry something. So just use one power source here. And that's about it. You can refer to this presentation later and see what type of resistors and capacitors you can use. You must just take your time and be very patient and to orient these parts correctly. Diodes must be oriented as noted, transistors, and everything else. Resistors can be placed any way you like. Ceramic capacitor also, but for tantalums, plus side must be on the plus side. And that's about it for this short presentation. I hope you'll find this useful tomorrow or any day you're gonna build this project. So that's it. Thank you. Do you have some questions? That's the trick question. Sound is in mono. Sound is in mono, but the same signal is routed on the left and on the right channel. And me and Voev just had a little conversation just about that. And this is the regular way. Maybe you must put some little resistor on both left and right channel, but maybe on the next iteration. But you get same signal on the left and the right. If you use a mono plug, I just wrote Voy about that. I gave this to a friend of mine to test it, and he placed a mono jack. And he short-circuited the output and ground, and we had no audio. So you must use stereo or put mono plug, but not to the end. But just use stereo plug. Okay, thank you. Some other questions? Okay, I plan to attend that workshop tomorrow. I'll try to help Voya and you, all of you that plan to build this thing yourself. If you are planning to build this controller on some later date, you can mail me at this mail and ask some questions. I'll try to help you. But my main advice to you is just take time. Don't rush. Most of people today tend to rush things, and electronics are not very forgivable with this rushing stuff. So take your time and be very careful about this. And you should have nice console and you can make something with your own hands, and that's very rare today. So that's one main appeal, at least to me. Yes. That's the question for the designer. I'm just helping here with presentation. Any other questions? No. So the answer is no right now. Well, I can try, but where is the technician? Yes, we can try to connect it. Well, we're gonna see.